Today, biologists and paleontologists regard the story of the serpent with legs in the Garden of Eden as simply that, a story. But surprisingly, they do have something to say about snakes with legs.
To the left, we have a savanna monitor lizard, and in my hand, right here, we have a boa constrictor. Two animals that look superficially very different from each other. But we know from looking at their anatomy, the fossil record, and their genetic sequences that these animals share a common ancestor about 100 million years ago. The snake body plan evolved from a body very similar to what we see in this lizard, with 4 limbs, a short trunk, and a long tail, into the body that we see in this boa, with a very long trunk, no 4 limbs at all, and no shoulder girdle, and a very, very short tail. And amazingly enough, if you look at some species of snakes today, you can still see the remains of their hind limbs. In this ball python, we can see the remnants of the hind limbs as these very small little spurs at the base of the tail. Within these spurs are very small thigh bones, ephemera, which are the only remaining elements left of the hind limb in primitive snakes.
It's hard to believe these tiny spurs are evidence that snakes once had legs, but recent discoveries of ancient fossils reinforce the theory.
These fossils were recovered from shell and marine rocks dated between 99 and 95 million years old. These snakes show the body plan that we can see in living snakes, such as this python. The amazing thing about these snakes is that complete skeletons have been recovered that include external hind limbs, including feet and toes.
Could this really be the fossil of an ancient snake leg? It just so happens that there is more evidence connecting this 95-million-year-old leg to modern snakes. Many living snakes today possess a specialized form of feeding called wide gape feeding.
Wide gape feeding in snakes is a specialization where the bones of the skull and the jaw joint are actually suspended far behind the rest of the head relative to other lizards. This allows snakes to have a very long lower jaw that can swing out very deeply. Additionally, the bones of the lower jaw are not fused at the front of the mouth as they are in mammals and other animals. Instead, these two bones remain separate, and when a snake opens its mouth, they're able to swing wide apart to create a very deep gape, which allows snakes to eat a variety of large-bodied prey.
Biologists consider wide gape feeding an advanced characteristic found only in snakes. The 99-million-year-old skulls discovered among recent fossils show adaptations for wide gape feeding. It means that these ancient skulls are definitely snake, not lizard, not dinosaur. And because the skulls are attached to skeletal bodies that have legs, they just may be a direct link connecting modern snakes to ancient snakes with legs. Could a fossil snake with legs be the great-great-great-grandfather of all modern snakes? It's an interesting idea, especially when comparing the Genesis story to the evolution of snakes. In the Garden of Eden, after being cursed by God, the serpent loses its legs. Modern science points to the fossil record and millions of years of evolution to show the same result. The serpent lost its legs as it evolved to burrow.
Today, primitive living snakes are all burrowers, which has led some people to conclude that snakes actually originated their elongate body plan and reduced limbs for a burrowing lifestyle.
And there is a burrowing beast that exists today that biologists classify under Squamata, the same lineage as all snakes and lizards. It is in the strange subcategory of Amphisbaenia, the worm lizards, where we find yet another suspect for Eve's serpent with legs.